Welcome to new video on Facts Planet. You often hear news saying that an earthquake of magnitude 7 or 8 on the Richter scale has occurred. In reality, the Richter scale is only used to measure small earthquakes, up to about magnitude 5. For larger earthquakes, we rely on another scale called the moment magnitude scale, which was invented in 1977 by two seismologists, Hiroo Kanamori from Japan and Thomas Hanks from the United States. This scale is clearer and more accurate than the Richter scale. But what would happen if the Earth were hit by an earthquake with a magnitude of 10 on the moment magnitude scale? Firstly, before discussing the terrifying consequences of such a catastrophic event, it is important to address some points. For example, if someone says that an earthquake occurred in a specific area, what would be the impact according to the mathematical calculations based on the geometry and dimensions of the Earth and the size of tectonic plates? An earthquake with a magnitude of 10 has no chance of occurring anywhere in the world, except in a specific location known as the subduction zone in the Pacific Ocean, which is part of the Ring of Fire. This region experiences about 90% of all earthquakes and seismic activity worldwide. Moreover, you can say that nearly 100% of large earthquakes exceeding magnitude 8.5 occur in this region, due to the nature and size of the tectonic plates in that area. It is also important to understand that each unit on the magnitude scale represents an increase in strength by a factor of approximately 32. In other words, an earthquake with a magnitude of 6 is about 32 times stronger than an earthquake with a magnitude of 5. So imagine if we were to reach a magnitude of 10. An earthquake of magnitude 10 would be an incredibly powerful event with devastating consequences. It would result in widespread destruction, collapsing buildings, massive landslides, and tsunamis of unprecedented size. The impact would be felt over a vast area, causing severe damage to infrastructure, loss of life, and long-lasting effects on the affected region. The energy released by such an earthquake would be astronomical. Fortunately, earthquakes of this magnitude are extremely rare. The strongest earthquake ever recorded on Earth was the Great Chilean Earthquake in 1960, which had a magnitude of 9.5. To date, no earthquake has reached a magnitude of 10. It is crucial to continue studying and understanding earthquakes to improve our preparedness and response capabilities, but it is unlikely that we will experience an earthquake of that magnitude in our lifetime. In order to avoid surprise at the vast difference in destruction between a hypothetical 10 magnitude earthquake and any other earthquake you may have heard of, including the most powerful earthquake recorded in history, Valdivia earthquake, magnitude 9.5, it is important to understand the exponential nature of the magnitude scale. The difference of half a magnitude on the moment magnitude scale represents a doubling of the earthquake's destructive power. So, a 10 magnitude earthquake would be significantly more destructive than a 9.5 magnitude earthquake. In the initial moments of a 10 magnitude earthquake, the energy release would be equivalent to approximately 15,000 megatons of TNT, or the energy of 1 million nuclear bombs the size of the Hiroshima bomb. If we imagine that the epicenter of such an earthquake was in the Pacific Ocean at a certain depth, and about 200 kilometers away from the nearest city, even with the distance, the impact would not be subdued enough for the city to remain intact. No city in the world, even with earthquake-resistant buildings, would withstand such a tremendous force. All buildings, roads, and infrastructure would collapse in the initial moments, and even wooden structures and trees would crumble from below. The amount of energy released from beneath the ground would propel debris into the air. This would be followed by fires, lightning, and other incidents resulting from the collapse. After about 30 seconds to a minute from the beginning of the earthquake, the effects of the massive shaking would reach distant cities far from the epicenter, generating new earthquakes and volcanoes away from the original epicenter. Depending on the infrastructure of the countries experiencing these secondary shocks, it is possible that some nations would face a fate similar to the countries and cities near the epicenter. It's important to note that a 10 magnitude earthquake is an extreme scenario and has never been observed in recorded history. The purpose of discussing its potential effects is to highlight the exponentially increasing destructive power as magnitude increases. Earthquakes of this magnitude are highly unlikely to occur in our lifetime, but understanding their potential impact helps in disaster preparedness and response efforts. Generally speaking, based on theoretical calculations, there is no meter on Earth that would remain unaffected by such shaking. Scientists suggest that the weakest seismic activity that would be recorded away from the epicenter would be around 3.5 magnitude. However, its impact in those areas would be minimal to the point that some people may not even feel it. But the real concern is not just the seismic activity. Within the first hour, or even before reaching the first hour, a giant tsunami wave would strike all coastal cities next to the epicenter. These massive waves act like vacuum cleaners, sweeping behind the main earthquake and carrying debris along with them. Buildings that survived the earthquake would still be swept away by the tsunami. Within a matter of minutes, navigation routes and trade would be disrupted as all nearby ports would be submerged. It is not unlikely that, after several hours, the tsunami would reach all the ports along the Pacific Ocean, causing trillions of dollars in losses globally and halting global trade entirely. Finally, to alleviate any concerns, it's important to note that everything mentioned is purely a theoretical assumption. Fortunately, based on real data, there is no chance of an earthquake stronger than 9.8 magnitude occurring because the size of tectonic plates does not allow for such a large earthquake, except in one theoretical case: the impact of a celestial body colliding with Earth, causing larger ruptures than what tectonic plates can produce.